Hello, am I audible to everyone?
Yes, sir.
Yeah, hi, Varun this side. Sunny will join in 10-15 minutes, I guess. Till then, I thought maybe we can have a little chit chat together. It's been a long time, right? So, how are you all? How it's going? How are the classes going on, guys? And what about the roast master who is going to roast Sanket? बोर हो रहे हैं यार, सब बोर हो रहे हैं, क्या करा जाए? संकेत को कौन रोस्ट कर रहा है? आई हर्ड देयर इज अ प्राइज मनी फॉर रोस्टिंग संकेत. कितना? डिपेंड करता है यार, कितना रोस्ट करोगे आप. संकेत सेशन छोड़ के चला जाएगा तो मेरी तरफ से फिर पूरा वीक चीज बस्ट. व्हाट अबाउट अदर्स? क्या चल रहा है? तुषार, उत्सव? डिस्कशन कुछ नहीं यार, ऐसे ही तफरी काट रहे हैं. सनी विल जॉइन इन 10 minutes, सो लेट्स, आई थॉट मे बी वी कैन हैव सम चिट चैट और ये सब. लॉकडाउन खुल गया आप लोग एरिया में? ओके. ज़्यादा सेशंस रह नहीं गए आई गेस. रोस्ट, रोस्ट एज इन मतलब इतना ह्यूमिलिएट कर दो उसको कि वो सेशन छोड़ के चला जाए. Sanket is the roast master, I guess, right? We can create teams as well, you know. We can create team of Team Sanket and Team ROI. Rest of DMux, ROD. बाकी लोग का क्या हाल है? अमन, दिव्यांशु, it's almost getting over, right? So when is the placement session starting in your colleges? In BITSCO or other colleges? Already started. कौन कौन सी कंपनी आ गया अमन? अगस्त, हाँ यार इस साल शायद पोस्टपोन हो जाएगा आई गेस. एक्चुअल में रियलिस्टिकली होना सितंबर अक्टूबर में चाहिए इस बार. प्लेसमेंट सेशन कई जगह स्टार्ट हो जाता है. हाउ इट्स गोइंग अमन? कौन कौन सी कंपनीज निकल गए? हाँ मोस्ट प्रॉब्ली आई गेस एनआईटीज में जल्दी होता है, जुलाई अक्टूबर, जुलाई अगस्त, बट दिस ईयर एनआईटीज में भी सितंबर अक्टूबर पुश होगा. अभी तक दिया नहीं एक भी. यार तुमसे काफ़ी उम्मीद है. हाँ हाँ, पैकेज अच्छा मिल जाएगा भाई, अभी तो जो मिल रहा है वो ले लो, सही रहेगा. अमेजोन ट्राई कर सकता है, अमेजोन बहुत हायर कर रही है अभी. अमेजोन का रेफरल चाहिए तो संकेत को बोल देना. वो वैसे भी अभी अभी अमेजोन निकाला है कुछ दिन पहले. आई गेस ट्रीट तो तुम लोगों ने ले ली होगी इससे. अच्छा, अमेजोन अगस्त में आएगी. अरे अभी लास्ट वीक निकाला, बताया नहीं क्या उसने? हम लोग तो हमारे भी थे, उसने वो क्लास नहीं ले पाया था, बैठ ही नहीं पा रहा था बेचारा. नहीं यार, तुम लोग को समझ में आ जाना चाहिए था, बहुत मार खाया था वो. हाँ. अरे आंख पे नहीं मारते भाई, प्लेसमेंट पे कहीं और मारते हैं. आप आंख कौन देखता है? हाँ जीपीएल. यूएस का ऑफर निकाला था संकेत ने. तुम लोग को मेरे को लगा पार्टी दे दी होगी शायद. हाँ, जूम पे सिर्फ शक्ल ही दिखती है, वही प्रॉब्लम है. जूम को फीचर ऐड करना चाहिए, राइट? और बाकी लोग क्या कर रहे हैं? सबका पैसा वापस? नहीं नहीं नहीं, ये नहीं होगा. आप संकेत से वापस ले सकते हो पैसा अपना. शायद 4 या 5 ही सेशंस बचे हैं यार अब मेरे ख्याल से. ग्राफ खत्म हो जाएगा उसके बाद एक दो सेशंस और हैं. उसके बाद मे बी वी कैन एंड दिस. हाँ देंगे ना यार, अमेजोन का रेफरल देंगे संकेत सर। अभी आजकल नेगोशिएट कर रहे हैं पैकेज को लेके, उसके बाद पार्टी भी देंगे, अमेजोन का रेफरल भी देंगे। कोर्स के बाद अभी आई गेस नया बैच स्टार्ट होने वाला है, समर बैच स्टार्ट होगा, बट स्लैक पे तो एवरीवन विल बी एडेड, और लिंक्डइन पे भी कनेक्टेड है, मतलब एक ग्रुप अलग से है, उस पर कनेक्टेड रहेंगे। आप सब लोग ज्वाइन कर लेना वो ग्रुप, मतलब वहाँ पे विल कीप ऑन पोस्टिंग, एंड जब जब जिसका प्लेसमेंट हो तो वो एक एक कुछ भिजवाता रहना यार, घर पे मैं एड्रेस भेज दूंगा। नहीं शादी नहीं हुई यार, शादी शादी किसी की नहीं हुई अभी तक। रेफरल किसी का नहीं मिल रहा है यार, मैं अभी थोड़े दिन पहले ही चेक किया था, सिर्फ अमेजोन ही हायर कर रही है। अमेजोन बहुत ज़्यादा हायर कर रही है, अभी कोई और हायर ही नहीं कर रहा है। आई एम इन बैंगलोर ज़्यादा, एवरीवन इज इन बैंगलोर ओनली। बाकी लोग ऑफ कैंपस ट्राई नहीं कर रहे हो क्या? ऑफ कैंपस ट्राई कर सकते हो यार इंटर्नशिप के लिए, एमएक्स में ट्राई कर लो, एमएक्स तो कर रही होगी हायर, वो तो हमेशा करती है। हाँ एक ही जगह है, वो भी है नहीं यार, फ्रीज है एमएक्स में भी। हाँ यार ऑफ कैंपस का एक कंपाइल कराएंगे, मतलब सोच रहे थे हम लोग भी, लिंक्डइन से एक कंपाइल कराएंगे लिस्ट जिसमें ऑफ कैंपस अपॉर्चुनिटी सारी है, वहाँ पे ज़्यादा के अप्लाई कर देना, और जहाँ जहाँ रेफरल हो सकता है वो फिर वहाँ इनिशिएट कर लेंगे। आई थिंक सनी सर हैज ऑलरेडी ज्वाइन। ठीक है
Hey,
मैं
hi.
निकल जाता हूँ।
Yeah.
हाय
Can you
सनी।
make me post? Hi, hi.
हम लोग तारीफ कर रहे थे आपकी।
Oh, wow, I missed it.
अरे इन लोग को बताया नहीं संकेत का प्लेसमेंट हो गया अमेजोन में यार किसी ने?
संकेत ने लिखा था ना ग्रुप पे।
संकेत ने ग्रुप पे लिखा, किसी को पता ही नहीं है।
Oh, yeah. So Sanket got placed in Amazon
अमेजोन एज अ डेटा
in
साइंटिस्ट।
Palo Alto. SD या SD2. Uh, I
डेटा साइंटिस्ट यार, एसडी छोटी मोटी चीज है उसके लिए।
okay. Yeah.
संकेत
पैसा ही
को बहुत
पैसा
उम्मीद
होगा. I
है।
guess so.
अरे बहुत पैसा है, अभी उसी से पूछना कितना पैसा है, मतलब मेरे को तो बताते हुए भी शर्म आ रही है। इंडिया का हाईएस्ट सीटीसी उसके मंथली उसके बराबर हो गया।
Cheese burst ही cheese burst. Yeah.
दिखाते तो बहुत है गरीबी, स्कॉलरशिप भी नहीं दी होगी किसी को पक्का यहाँ पे। चलो फिर आप करो सनी सर, ओके आई लीव।
हाँ. Can you make me the host?
मेकिंग वेट। चलो ओके,
Thank you. Yeah.
we will
See
meet
you.
towards the end, and we can have some fun as well. बट रिमेंबर जो संकेत को रोस्ट करेगा उसको चीज बस मेरी तरफ से है, तो जस्ट प्रिपेयर। बाय।
हाँ ओके मैं भी करूँगा रोस्ट बाय बाय हेलो पीपल हाउ आर यू कोई दिख नहीं रहा है ओके दिस इज जस्ट मी ऑल गुड नाइस एंड डिड यू प्रैक्टिस एनीथिंग ऑन ग्राफ्स or were you enjoying your weekend so today सो रहा था 3 महीने से वीकेंड ही है या आई थिंक इट्स सेम फॉर एवरीवन क्या करें अब yeah so today we will do questions on whatever we have discussed so far and the plan is to discuss like how to approach the questions and if if you guys want, I can share the codes later once you have tried. So I don't want to I don't want to show the like the full solution right away. I want you guys to try it, code it, and then we can match our solutions. Does that sound good? काश हमें भी Amazon लग जाता लॉकडाउन में. Yeah. So when I heard first that Sanket got Amazon, I was thinking कहीं delivery guy तो नहीं बना है, because that is the most like demanding career right now. Anyway. Roast, yeah, roast has started. So did you guys try the course schedule problem? I'm just pasting the link in the chat. So is there anyone who doesn't know the question? Or can somebody unmute and just explain the question to everyone, like what the question is about? What do we want to do? And then we can talk about the solution. Come on, guys. Anyone? Okay, so let me get started. Let me explain the question and we can take your help from the next question. Okay, so the question is about course schedule, and you're given that there are total like n number of courses or num courses, number of courses that you have to take. Now, each course has a prerequisite and is expressed as the pair. So you can think of it as an edge in a graph. So you are given the graph in form of edge, and this is a dependency graph. So we want to see whether you can finish all the courses given like under these dependencies. Okay, can you not see my screen? Can you see my screen now?
Yes.
Okay. Yeah, so let's take the first example. So the first example says that to take course 1, you have to take course 0, right? So what is the dependency graph here? So the dependency graph here is node 1 is dependent on 0. So 0 is parent of node 1. So can you complete the courses? So basically you want to, the question here is asking whether you can have a topological sort or not, right? That's the question. So for example 1, where did my whiteboard go? You share whiteboard, share, yeah. Okay, let me write it here. So example 1, oops. So example 1, what is the graph? Let's draw that graph. So the graph is that course 1 is dependent on course 0. So for topological sort, what do? We first see whether it's a DAG, right? is it a DAG? Yes, the edges are directed. There are no cycles, so it's a DAG, right? And can you tell me orally what will be the topological sort? So what does topological sort do? So it says that parents should come before children, right? So here the sorting will be 0, 1, right? So if you take courses in this sequence or in this order, 0 first and then 1, you can finish all the courses. Okay, let's take example 2. Where did the Chrome go? Yeah, example 2 is 1001. So what will be the dependency graph? So 10 means 0 points to 1 and 10 means 1 points to 0. So is it a is it a DAG? Can you have a topo sort for this? It's not a DAG, right? Because it has a cycle. The cycle is this 2-node small cycle. So like whatever sequence you take, you cannot finish the courses because both are dependent on each other. So if somebody says take 0, 1, you cannot take it because 0 requires 1 and 1 should come before 0. And if someone says take 1, 0, you again cannot take it because 1 requires 0. So like it's a deadlock condition. You cannot have a topological sort in this case. So in our algorithm, what should we do? Like how should we solve this problem? How so we know the algorithm for topo sort. How should we modify it slightly so that we can say whether topological sort exists or not? So if there's a bidirectional edge, it's not a DAG. Yeah. So here there are like, yeah, this edge points in one direction, this edge points in the other direction. So it's not a DAG. So if there's a cycle, it's not a DAG. That's a general thing. Topological sort we already know, right? So what is the first thing which we do in topological sort? The first thing in topological sort which we do is we check whether there are any nodes which have 0 in degree, right? We start from those nodes. These are the nodes which we first push into the queue, right? If you remember. So if you think of that step, would you push anything into the queue in example 2? Is there any node which has in degree 0? No, right? So you can run the same algorithm, topological sort, and at the end you can just check whether you have covered all the nodes. So how would you check that? So in topological sort, you push nodes to topo list, right? So topo list was our order, right? And you push nodes to it. You do topo list dot push back node, right? So at the end, you can just check whether like size of topo list is same as number of nodes. So if size of topo list is same as number of nodes, that means you have a topological order, and that means you can cover the courses. And if this doesn't happen, so as in example 2, you won't have 0 or 1 in the topo list because they won't go into the queue anytime because they won't have in degree 0 at any point of time. So does this sound valid? Are there any confusions here? So you have to just make this check at the end of our topological sort algorithm. Does that make sense? Yes, no. Awesome, awesome. Okay, so that was about the question we started yesterday. Let's do one more related question. I think that will be easier for you guys. The question is part 2 of the same question, that is course schedule 2. The link is in the chat. Read the question and try to relate it to whatever we have discussed. Don't jump into the solution right away. Think about it. See what kind of graph it is. See what it is asking and what algorithm you can use from whatever we have learned so far. So this is easier than course schedule, right? Because this is very straightforward. So is my Chrome visible? Okay. So what does the question say? The question is the same. The graph structure is the same dependency structure among courses. The dependency is given by the edges in form of list. Now we want to find the ordering in which you should finish the courses. So does it sound very familiar? So it's straight away the topological sort, right? So it's asking for the ordering in which you can finish the courses. The first part was asking if you can finish the courses. The second part is asking what order would you follow. So it's straight away topological sort. And if it is impossible to finish, return an empty array. So what would you do in that case? Like similar to first part, right? You will just check if the the size of topolist is same as number of nodes. If that is the case, just return the topological sort. If that is not the case, just return an empty list. Okay. So can everybody do this? Feel confident about it? Is there anyone whom I left behind or who wants me to explain this? If you don't understand, please speak up. Okay. So yeah, don't shy away, please. Okay, so let's move to the next question if we all are good with this. So the next question is sequence reconstruction from LeetCode. and I've pasted the link in the chat. Um, go through the question and try to see, try to formulate a graph problem out of it and see how can we solve that. So if I think you will have to use DSP batches login to see this question, because this is, I think this is a question which is like logged for free users. Yeah, so the login is DSP batches. The password is DSP batches 11. Yeah, 11. DSP batches 11. What does that mean? Is there any significance of 11? संकेत सर से पूछते हैं. Sequence reconstruction. So have you guys read the question? Can anybody explain what the question is asking about? What are we supposed to do here? So once we understand the question, then we can start thinking about, okay, how to go about the solution. Okay, so let's see what the problem is asking about. So, where did my whiteboard go? Yeah. So the problem says that there is an original sequence ORG, and this original sequence is a permutation of integers from 1 to n. Okay, so there is a sequence org, which is some original sequence, and this is a permutation of integers from 1 to n. Okay. N has some bounds, that is fine. So reconstruction means building a shortest common subsequence of the sequences in sequence array. So there is another sequences array which has some sequences. Okay, and now there is an operation reconstruction. What does that mean? So reconstruction means building a shortest common super sequence of the sequences. So using these sequences, we want to build a super sequence. Okay, such that the subsequences of this super sequence are these. So if you take this bigger sequence, this bigger sequence has these smaller strings as subsequences. Okay, and so what is the question asking? So the question is asking, determine whether there is only one sequence that can be reconstructed and whether if it is org sequence. So if we perform this reconstruction operation, we have to determine if this is unique and if it is unique, is it same as org? Okay. So also, like if at any point of time my voice breaks, just let me know, because I think the internet is a bit shaky. So let's take an example and let's try to see what is the question about. So we'll take example one. So the example one says the original sequence is 1, 2, 3, right? And the array of sequences, what is that? It's 1, 2 and 1, 3. So we want to do a reconstruction so that the super sequence has these subsequences. So if I tell you, okay, reconstruction is this super sequence. So does this super sequence have both of these components? So it has 1, 2 and it has 1, 3, right? As subsequence. So it has both, right? So this is a valid super sequence. Now let me also write another valid super sequence and see. So I'll write this. So is it a valid super sequence? Yes, it is again a valid because it has 1, 3 and 1, 2. So this is a valid. So what does validity mean here? So the validity means here that 1 should come before 2 and 1 should come before 3. So then it will be the subsequence of the super sequence, right? So if it comes before 2, can you think about like what are we going about? Like, is this kind of dependency here? Can you think of a dependency here that, okay, there should be a directed arrow from this to this and a directed arrow from this to this? So in terms of graph, if I write something like this, and now I think about Okay, I want to build a super sequence, and I think about topological sort. So the topological sort could be 1, 2, 3, and 1, 3, 2, right? So both of them are valid super sequence. So can reconstruction step be thought in terms of toposort? Yes. Okay. Awesome. Now let's take example 2 and again like verify our, or let's take example 4. I think that is more complex. So example 4, what is the original sequence? Original sequence is 415263. And what is the array of sequences? 5263 and 4152. 5263 and 4152. Okay, now let me, so I was thinking about a graph, dependency graph. Let me use that method and try to see whether that works. Okay, so what I will do is graph, and can anybody help me create that? Can anybody, like someone from you guys, speak and help me with that? Anyone? No, you don't want to help me? You'll only help Sanket. Okay, that's cool. I will help myself. So the graph here will be for the first string, a linear chain, right? So 3, 5 should come before 2, 6 should come before 5 and 2, 3 should come, I mean 3 should come after 5, 2 and 6. So in this order they should appear. 5 should come before all of this, 2 should come before 6 and 3, and so on. So this is the dependency graph for the first part. Okay. For the next part, what will be the dependency graph? So 4 should come before 1, 1 should come before 5, and so on. So did I get a complete graph here? So this is part 2 and this is part 1. Cool. And what will be the topological sort here? It's a linear chain. So for a linear chain, it will be like you will remove this node first. Then this becomes the node within degree 0, 1. Then 5 becomes the node within degree 0. Then you have 5 and 2, 6, 3, right? So this is the unique topo sort here. And is it same as original? Yes, it is same as original. They both are same. So unique topological sort, same as original. So answer is true. And if you have multiple topological sort, the answer will be false because then it won't be unique, right? But in this case, it is unique and same as original. So the answer is true. So do you guys have a sense of what algorithm will be used here and how do we solve it? There is one piece missing here. Like how do we ensure that it is unique? How do we check that? No branches. Branching. Branching have any effect? Uh, so in terms of topological algorithm, like toposort algorithm, can you think of which step will ensure that we can't have multiple strings? So when would we have multiple topological sorts? When we have two nodes with in degree 0 at same point of time, right? Then you can take either of those two nodes, right? So for example, uh, I hope you can see my whiteboard. Yeah. So for example, uh, this case, right? 1, 2, 3, 4. This is a DAG. This does not have cycles. It's a directed graph. So this will have a topological sort. And when you try finding the topo sort, what will happen is you will have initially 1 in the queue, right? So this is my queue. This will have initially 1. And when you pop 1 out, this goes out. And these two arrays, these two edges get deleted. And now the queue will have two nodes, right? So queue always has nodes which are nodes with in degree 0. So can you say something about what should be the size of queue at any point of time to ensure a unique topo sort? 1, right? So now can you think in terms of algorithm? Where would you make that change? So when you are pushing to the queue or in the topological sort, you can just add a check to make sure that you have just one option. Like in the algorithm, you have to write one if condition to ensure that you have just one element in the queue. Does that make sense?
So could you repeat the whole thing?
Yeah. So what I'm saying is, I was thinking about a case when I will have multiple topological sort. Okay. So I took this example and I said, let me see how Q looks, how our Q data structure looks when I run topological sort for this algorithm. And then I found, okay, initially Q will have element 1 in it, like node 1 in it, right? And after I pop node 1 out, I will delete all its outgoing edges, right? And this goes into my topo list. So my topo list will have node 1 in it. Now when I update the queue with neighbors of 1, I will add 2 and 3 both to it because now both of them have in degree 0, right? And what does that mean? That means that if Q has multiple elements, I can take um, like any of them, right? At this point of time, I can either take 3, 2 or 2 or 3. So I should ensure that the size should be 1. to have a unique topo sort. Does that make sense?
Yes, sir.
So in the algorithm, I'll have to make this small modification um, to ensure a unique topological sort, and at the end I will have to check whether the topological sort is same as the original ORG array. Can anybody think of any other way in which we can solve this? Like any other way of checking uniqueness? Or is there any flaw in this argument that there should be just one element in the queue? Okay, I think we are good then. And you should try coding it once you get time, and let me know if it works fine. Okay. So everyone happy with this question? Should we move to next one? Okay, all happy. Let's see the next question. So the next question is from LeetCode, again from LeetCode. It's called reconstruct itinerary. Also, at any point of time, if you feel you want solution, like code solution for any question, just let me know. And but just try once from your side. Okay, I'll also share the base codes which we wrote yesterday, like for topological sort, Dijkstra's, BFS, DFS. I'll share all of those on Slack. Sir, we will find all topological sort and choose one with the smallest lexicographical order. Okay. You will find all. So can you explain me the question first, Tushar? What is the question asking?
इसमें मतलब एयरलाइन टिकट्स हैं और
Okay.
हाँ तो एक डिपार्चर एयरपोर्ट है, एक अराइवल एयरपोर्ट है।
Mm-hmm.
हाँ तो कोई आदमी है, मतलब वो सबसे पहले JFK से चालू करेगा।
Okay, so there is an array of tickets with arrival and departure A1, D1, A2, D2, and so on, right?
हाँ सर।
Not necessarily in this order.
हाँ
And there's a man who starts from JFK.
हाँ सर। तो हमें एक ऐसा ऑर्डर फाइंड करना है जिससे हम सारे वो
Yeah.
कवर कर लें, मतलब जो लेक्सियोग्राफिकल सबसे छोटा हो और हम सारे एयर क्या बोलते हैं एयरपोर्ट्स भी कवर कर लें।
Do we want to cover all the tickets or airports?
हाँ टिकट्स, मतलब वही ये जितने भी
Okay.
अलग अलग हैं वो सारे कवर करने हैं सबसे और उसके अंदर सबसे
So,
छोटा वाला चुनना है।
so do all flights basically
हाँ
starting from JFK? Starting from JFK and find the smallest lexicographical order, right?
हाँ सर।
Lexicographical order. So let's take one example and try to understand. So which one should we take? Let's take, oh my God, 2 is very big. Let's take 1. So can you tell me what the example 1 is? Just help me with that.
MUC LHR, MUC comma LHR,
Okay, let me write it in small. Yeah, MUC LHR.
and then JFK MUC,
JFK MUC.
and then SFO SJC,
San Francisco, San Jose, and
LHR SFO.
LHR SFO.
Yes sir, that's it.
That's it. Okay. So man starts from JFK, right?
Yes sir.
So if the man starts from JFK, there is only one possible way to go. So he will have to go MUC,
Yes sir.
right? Now once the man lands on MUC, there is again only one possible way forward, that is LHR.
Yes sir.
And once he
SFO,
lands on LHR, he has to go to SFO,
then SJC.
and from SFO to SJC. So there was only one possible way here, right?
Yes sir.
Okay, this was maybe a trivial example. So in example 2, you can see from JFK, he has 2 options. From JFK, the man can go to SFO or to ATL, right? And which one should he choose? He should choose ATL because that will be lexicographically smaller,
Yes sir.
right? Is it clear to everyone? So that is why the output contains JFK, ATL, and so on, and not JFK SFO, because JFK SFO is like larger in lexicographically. So is question clear to everyone?
सर वो एक डाउट था कि
Yeah.
वो JFK से ATL गया और
Right.
आगे आगे वो ATL से JFK भी जा रहा है, तो ये मतलब लूप है क्या कुछ, मतलब?
So yeah, so JFK से ATL and ATL से back to JFK. So
But
this is a loop.
टोपोलॉजिकल सॉर्ट असाइक्लिक ग्राफ में लगता है ना बस, तो हमें अलग अलग लेके चलना पड़ेगा क्या उसे, मतलब दोनों JFK अलग अलग?
So do you need topological sort here? The question is that, like can we do else? Like there can be cycles, like even there can be bigger cycles, right? So there can be cycles like if you started from JFK, then you went to ATL, then you went to NYC, and then you came back to JFK, right?
तो
Cycles
हाँ,
are definitely possible and valid in this case. So
तो
maybe topological sort is not a good idea because it has cycles.
yes,
Can we do something else, like
लाइक सिंपल रिकर्शन, वो ऑर्डर याद रखते हुए, मतलब लेक्सिकोग्राफिकली स्मॉलर वाला, JFK से स्टार्ट करके.
right? So basically what I want to do is I want to do a simple traversal, right? I want to do a graph traversal, but I want to ensure that lexicographically everything is small. And when I think of graph traversal, there are two options, DFS and VFS. So which one sounds a better option here? Does VFS sound a better option? So what will BFS do? So if there are two options from JFK, let's say SFO and ATL, VFS will say, okay, go from JFK to SFO, also go from JFK to ATL simultaneously. So that is not the realistic scenario because, right? So BFS is not a good option. The only option we have is DFS. DFS is a natural like traversal in this problem, right? Now we have narrowed it down to a graph traversal. We have some idea that it should be DFS. How can we ensure the lexicographical order now? Can I do something in adjacency list to ensure that it is lexicographically ordered? Yeah, so I can just sort the adjacency list, right, for each node. Then my DS will naturally take the first neighbor and then give me an order which is lexicographical, right? So DFS, you will do DFS with adjacency list, and these lists should be sorted. Okay, do you agree with this solution? Will it give whatever we want, like the smallest? And can you guys implement it? Do you feel confident? How to handle cycles? So DFS will handle cycles, right? DFS is not worried about cycles. Visited array will take care of, like, DFS is simple graph traversal. They will handle cycles. There is no problem with cycles there. Does that make sense? Very easy question, or should we? Is there any other explanation required here, or are we done?
Sir, I have a doubt.
Yeah.
Like, uh, if it has cycles, then every node Like you see in the example too,
Mhm.
JFK to ATL and then ATL back to JFK.
JFK to ATL. Okay.
Uh, then ATL back. Yeah. So if you would start a DFS from JFK,
Mhm.
then you would mark it as visited, and then again for ATL you would not come back to JFK.
Yeah. So the sequence will be JFK to ATL, right?
Yeah, but in answer you would include every node only once if you are doing
Uh,
DFS.
right. Yeah. So a node can come multiple times. That is right. So in visited array, do we need to keep a Boolean thing or like what do we need to keep? So should visited be 0, 1 or should it be an integer? Should it be frequency? So initially my visited array had all 0 and 1s. It was kind of Boolean. Right? And here I should make that to some frequency. And how will I get that frequency? That I'll get from the list of tickets, right? Arrival, destination. That how many times should I come to JFK? And so what will happen in that case? So let's take that case. So the question is, if I have JFK ATL and then ATL JFK, uh, how should I do that? So basically you're visited will have so your graph will be basically JFK ATL. So there is one arrow from JFK to ATL and then other arrow from ATL to JFK. Right? And initially you are at, or let's take maybe a bigger cycle, then it will be better. So let me come back to ATL again maybe. So there is one more path. Does it say it can have parallel edges? If there are multiple valid itineraries, you should this all airports. You must assume that all tickets form at least. Okay. Let's say if there was JFK comma ATL again. Okay. So this is my graph.
तो वेटेड ग्राफ
Now,
ले रहे हैं ना?
yeah. I mean, you can think of it as weighted as well.
मतलब वेटेड ले लेंगे तो अगर वो 2 बार आए तो 2 कर लेंगे और डीएफएस टाइम उसका वेट रिड्यूस करते रहेंगे राइट.
Right. Yeah. So how many times should you come to JFK? You should come like once, right? Or if you are saying that, okay, we start from JFK, it should be 2. If you reduce for the initial state as well. So you start from JFK, then you again come back to it. So it is twice, right? And how many times you visit ATL? you again visit ATL twice, right? So you only count the arrivals of any place, right? How many times you come to a place. Because if you have come to a place, you will naturally go out. So how many times you come to a place, that is 2. And how many times do you come to JFK, that is also 2, because 1 is this is 1, and the other 1 is your initial start position. So basically you can count all the in degree for each node, and you can like fill up the visited array accordingly. Right, and then you can do BFS, like DFS, using this visited array which has in degree populated. So
Okay, so
your DFK will
until
have
its
to
frequency is
18.
uh, until
Your
its
voice is breaking. Yeah.
until its frequency is greater than 0, we would visit it.
Yeah, until its frequency is greater than 0, you will visit it.
Okay. So I am getting it, but can you prove it like it would always be correct, like for a general case?
Proving, I mean, what kind of proof are you imagining?
So basically, like correctness of this, like
So there are 2 parts to it, right? One is lexical graphical order, right?
yeah,
That we are ensuring at every step, we are ensuring that we are getting a smallest string.
yeah, that I get.
So that is correct. And the other is cover all the tickets, like all the paths. So that we are doing using DFS, and the visited array which we are taking is the frequencies. So we ensure that we come like 2 times to ATL.
And we would not, and we would do like include, like we would do it for all the edges, and neither of the edge
For
would,
all the edges, yes.
and neither of the edge would be repeated, so our answer would be correct.
Yep.
Okay, fine.
Yeah. So yeah, we can code it, but you guys want to try it first, coding yourself, because it's a small tweak. I mean, it's not a big change. So once try it at home, and maybe later tonight, like my night, I can share my code. Or if you guys want a day or two to try it, like, yeah, take some few days and then I can share the solution. But yeah, now the algorithm is complete, I guess,
So
because
could you briefly explain the approach?
so the approach is using DFS. Do you understand till that point?
Yes, sir.
And for DFS, we are saying we will sort the adjacency list. Do you understand second point?
Yes, sir. Adjacency list.
To get, yeah, and then we are saying the visited array should have this in degrees, because I can visit the same place multiple times. So if you look at this example, when I start from JFK, I'll go to ATL, that will be my first. And if I take visited as Boolean, then I can't go back to JFK, right? So I'll have to have some frequency, like how many times can I visit JFK? So then I'll again, if I have the frequency, how many times I can visit JFK, then I can visit a node multiple times. And I'll visit the node for 2 times. That is the frequency. Then again, I go to ATL because again, I can visit ATL 2 times, and this is the second time. And that completes my overall traversal. So the traversal here will be JFK to ATL, and then ATL to JFK, then JFK to ATL. Okay, so this will be my order. Do you understand it?
Yes, sir.
Yeah.
Sir, but the DFS part, how like we are going in deep, right?
Yeah.
In what way you're relating to here?
So you will go deep because, and you will go to the first neighbor, which is smallest lexicographically. And here the only neighbor for ATL is JFK. So you will go to JFK. So if there was some other neighbor of ATL, let's say BLR, then you've gone to BLR first. Because that is like B smaller than J.
Yeah, okay.
Okay. Yeah. Nice. So this was about reconstructing itinerary. So this was a good DFS question, and I think it's a good modification. Nice question. I like this question. So try coding it up. Let's move to next question now. So the question is from interview bit, and let's see how, like, we have done a similar problem in class, and let's see if you guys can come up with some algorithm on this. So this question, I will not help you with algorithm. I want you guys to come up with the algorithm, and then I won't spoon feed you with any algorithm for this question. I want you guys to help me here. So the question is on interview bit. The title is capture regions on board. So Aman had said something. Basically, we are finding a Hamiltonian path in a directed graph, right? I don't know what Hamiltonian path is. Let me quickly Google it. Hamiltonian path. Hamiltonian path is an undirected graph that visits each vertex exactly once. No, so this is not an Hamiltonian path because we will visit vertices many times. But I got it accepted using the same. So how would you get, for example, 2 then? Like, which will have 2 ATLs and 2 JFKs. You can try seeing, like, according to the definition, I don't see why this is an Hamiltonian path, because you are visiting vertices multiple times. But in the code, you should see like how you're getting, like, visiting multiple times single node. Maybe that is the right solution, like you're doing something for that in the code. So Kushagra says this is like the island one which we solved earlier. Yeah, so it's similar to the island one which we solved earlier. But how would you do this? Kushagra, can you explain us the question and then we can discuss about the solution? Can anyone explain the question, please?
uh,
Yeah.
what I think the question is, like,
Yeah.
if we have to flip all the zeros into
Mm-hmm.
x into x's,
Mm-hmm.
whenever the connected components formed by the zeros is supported is uh, like surrounded by x from all the sides.
Right.
So obviously all the zeros on the borders, like
Right.
except the borders, all the zeros which would be inside would form a connected component or would be surrounded by x on all the sides. If
So,
if 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 they are not connected to the zeros
mm-hmm.
on the borders through any path.
Right. Right.
So what we could do is we could do a BFS of all the nodes that are on the border
Right.
of all the zeros that are on the border of the matrix,
Correct. Yeah.
and all the remaining zeros we could turn them into x.
That is right. Yeah. So basically what you will do is you will take all the zeros on the border, you will mark them, like you will do a DFS from there or BFS from there, whatever you like.
Yeah.
Only on zeros.
Yeah.
And you will mark them with some other marker. Let's say some other marker is
Hash.
W.
Yeah.
Yeah, something, whatever you like.
Yeah.
And those all won't be completely surrounded by X.
Yeah.
And whatever zeros remain after you have done like multiple BFS or DFS from all the border zeros,
Yeah.
the remaining zeros will all be surrounded by X and you can convert them to X. And then you flip back all the W's or whatever character you have used to zeros.
Yeah.
Yeah, I think that is right. So for other people, let me explain the question. So the question is that we have a 2D grid. The 2D grid has two characters, zeros and x's. And the question is asking to convert all the zeros to x's if they are surrounded by x's on all the sides. So let's see what that means through an example. So input 1 has 4 rows and 4 columns. So it's a 4 cross 4 grid. The first row has all x's. So all x's. The second row has 2 zeros in the middle. So it's 0, 0 and x on both sides. The third row is 0 on the third position. And the fourth row is 0 on the second position. So this is the input, and let's see, let's look at each zero. So is this 0 surrounded by x's on all the sides? So let me look top. Yeah, it is surrounded. Left, it is surrounded. Right, yeah, this is surrounded by this. Bottom, yeah, this is surrounded. So this 0 should change. So I will mark it with green. Yeah, this should change. Let me look at the other 0. So this 0, is it surrounded by x? Yes. On the top, yes. On the left, yes. On the right, yes. On the bottom, yes. This surrounds. So this should also change to x. And what about this particular 0? This is also surrounded by x on all sides, right? So this should also modify to x. And the only 0 which is remaining and which will not modify to x is this 0, because it is surrounded by x on 3 sides, but not on this side. So this will remain as is. So what will be the modified matrix? The modified matrix will be x, 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 and then these are the two new x's, and then again x, then again a new x, and then x0, xx. So this is the output. So this was your input and this is the output. Okay, so what Kushagra gave us an algorithm. What he said was like all the zeros on the border won't convert to x because they can only be they'll have only at most 3 axes which will cover them on these 3 sides, right? One of their sides will always remain empty, so they'll always remain 0. So basically what do you do is just run a DFS from all the border nodes, like border zeros, and mark all these border zeros and their connected zeros with some character. So okay, so let's say if this particular x was also 0, so this becomes 0. So these two zeros will remain 0 because again this 0 is not covered on x by x on this side. So what Kushagra said was like do a DFS from border zeros and cover and replace all this with, let's say, W or some other character, and do this DFS thing for all the zeros on the border. At the end, you will have a matrix of W, 0 and X, right? In this, convert all zeros to X. So basically you will have W and X, and then convert all W's to 0 back. So you will have your output. So your input is 0 comma X. By running multiple DFS, or BFS, whatever you like, you convert it to W0X and then you make these changes. So is the algorithm clear? So basically you will run the graph traversal for zeros from the border zeros. Does that make sense?
So from where the W came?
So W are the modifications W are the zeros which don't get modified. So we are just marking them differently. So these are non-modified zeros.
Yeah, okay.
So all the border zeros will be non-modified and all the zeros connected with border zeros will be non-modified. So border zeros and connected to them and zeros connected to them will be W's. Okay. Simple enough. Is there anyone who doesn't understand the algorithm, or are there any doubts, questions? If you understood it, say yes, no, maybe, whatever you feel. Yes. Awesome. So you have done a Google question. Congratulations. So this was a question from Google. So if we recall what all we have done today, we have done few questions on topological sort. We have done a good question on DFS. This question again on traversal, you can use BFS or DFS. So basically we have tried to cover most of the algorithms we have studied. Before moving to next question, I have to make few notes from whatever we have discussed. So yeah, let's talk about time complexity of all the algorithms which you have studied so far. So time complexity for BFS, DFS, Dijkstra's, and Toposort. Okay, and that is first. And next, okay, one more small note is there that we'll do after this. So time complexity, come on guys, this is your MCQ for Microsoft. What is the time complexity of BFS? Order of V plus E, right? So what we do in BFS basically is, first of all, you have a visited array. So that is of size V, like all the vertices. And during the algorithm itself, you traverse every edge. So you go to all the neighbors and you do that using all the edges. So that is E. So the complexity is V plus E. Okay. Same for DFS, order V plus E. Any confusions here? So this is an interesting one, Dijkstra's. What do you think will be the complexity of Dijkstra algorithm? So basically Dijkstra algorithm has multiple iterations, and what do we do in each iteration? In each iteration we find a min, right? And what else? We update neighbors, right? We update neighbors and probably push them to heap. Heap or priority queue, whatever you call it. So these are the two things which we do in each iteration. Finding min is order one. So this is the primary step which we should care about. So what do we do? Like, how much time do you think this takes? So basically, what can be the maximum size of the heap? So heap contains the basically heap is updated for each edge, right? Whenever you get a new edge, whenever you add a new node to the processed side, you update all its neighbors. So basically a heap can be like, you have to think in terms of edges, and heap will add basically at most one element for each edge. So the maximum size of heap will be mod E. This is the upper bound basically. And how much time will it take to push an element in a size of heap E? So that will be log of E, right? And you do this log E operation for all the neighbors of a particular node, right? Sum of all the neighbors of a particular node. And you do this for every node. So I can write sum over all the neighbors. So what is the number of neighbors? That will be E. Can I write it as E log E now? Right? So basically Dijkstra's algorithm runs for V number of steps, like for every node. In each iteration, you have one node, right? You get minimum distance to one node. So it runs for V iterations. And for each iteration, what do? You update it for all its neighbors, and that updates take log E. So how many neighbors are there in total? So I'm adding it up for all the nodes, for all V vertices. So the number of neighbors could be E, because neighbors are connected through edges. So the time complexity will be E log E. And one more trick, E is order of V square. How do I get that? Basically, how many edges can you have at most? You can connect all the nodes together like VC2, right? E can be at most VC2, and which is order V square. So if I replace here E with V square, what do I get? Order of 2E log V, right? So Dijkstra's algorithm time complexity is E log V. Is that clear? Anybody who has any confusion here, just let me know, or if that is clear, think about toposort. So topological sort is also order V plus E. Right? So you have the in degree array, which is of V size, and then you traverse every edge. You traverse all the neighbors basically. You decrement their in degree. So you traverse all the edges. So it will be order V plus E. So these are the time complexities of the algorithms which we have discussed so far. There is one more thing I wanted to briefly talk about. That was Dijkstra's algorithm won't work when the edge weights are negative. When the edge weights are negative, the Dijkstra's algorithm won't work. So what will be an example of that? So let's see. Let me take a 3-node graph and node 1, node 2, node 3. Now I have to put some edge weights, okay? Let's take a undirected graph. That is better. So this, and this. So I want to find the shortest path to every other node starting from 1. Okay, and the edge weights are, let me put some edge weights. So the edge weights are, yeah, let's see. So the edge weights are 5, 7 maybe, and minus 10. So one of the edge weight is minus 10 and the other two was positive. So this is a negative edge weight. So what does our Dijkstra's algorithm say? Initially our process set has only one. Okay. The other side we have 2 and 3. They are directly connected with edge weights 5 and 7. I pick up the minimum. So I pick up this. And 2 moves to the process side. Okay. So it becomes 1, 2, and 3, right, on this side. And what is the shortest distance from 1 to 2? It is 5, according to Dijkstra's algorithm. Now, what are the edges from process to unprocessed side? There is an edge which is from 1 to 3, which is 7. And then there is an edge which is from this edge, minus 10. So what is the weight of this path. So 1 to 3, so this path weight is -5, and 1 to 3 part weight is 7. So I pick up the smaller one, -5. So 3 comes on the process side, and the distance becomes, this becomes the shortest path to 3, right? With weight -5. So this is the output of Dijkstra's algorithm, that shortest path to 2 is 5, shortest to 3 is -5. Is it correct now? So for 3 it is correct. It's the shortest path with weight -5. But for 2 we could have a smaller path which is from this direction, right? 7 to -10, and that would have formed a path with weight -3. So this was not correct. So basically it violates the assumption that you can take a bigger weight. So our assumption for the Dijkstra's was, if all the weights are positive, I can take the smaller one, right? But that assumption only holds when all the weights are positive. If there are some weights which are negative down the way, then the start you can take bigger weights as well. So Dijkstra's algorithm basically breaks for negative weights. So as we saw in this example, Dijkstra's algorithm won't work when the edge weights are negative. So a small note, you won't find this in any question, like you won't find negative edge weights, but you can have a small MCQ like, does Dijkstra's algorithm work for negative in all cases, all weighted graphs? So the answer is no, it won't work for all weighted graphs. It will work only for weighted graphs which have positive edge weights. So does that make sense? Yes, no? Okay, awesome. So those were the two small things. And what's the time? Oh, it's 10:50. I have a meeting in 10 minutes. I can post some more questions on the group for you to practice, and we can probably move to next topics tomorrow. Yeah, let's see. We can cover probably Maxflow, Mincut, and Prim's algorithm. Let's see what we can do tomorrow. Okay, if you have any doubts so far, I'm here for another 5 minutes. Otherwise, yeah, you can go back, sleep, have a sleep, practice a lot then tomorrow morning. And then we'll meet again tomorrow night, same time, 9:30 p.m. Sounds good. Okay, so we can close here. Bye guys, have a good night. See you tomorrow.